So, but I think in the interest of time, I'll start to give Riccardo as much time as possible to present his work. So, welcome to today's lunchtime webinar put on by BIM Copenhagen. And today we have the pleasure of hosting Riccardo Piazzai, and he'll be presenting artificial intelligence shaping the future of AEC. And I think this is a topic that's close to everybody's hearts these days with the explosion of ChatGPT and other AI tools that have taken over the market. So on one unfortunate, sad note, last night when I was putting this together, I learned about the passing of Jay Zalin. And if you don't know Jay, he's been a fixture in the BIM and digitalization community for a long time. He's a fixture at Autodesk University, built conferences, and the president of the Los Angeles Revit Users Group. It's really unfortunate to lose him, and it's all too soon. So, but back to BIM Copenhagen. We're a volunteer organization, and we have this steering committee where we try to put on events and find the best people possible in the AEC industry to put on these webinars and in-person events at Blocks Hub. So if you have any ideas, please reach out to us and we'll try and build a webinar or an event around your presentation. And this would not be possible without our sponsors. So we're excited to say that we've gotten a new sponsor since last time of Henning Larsen. And without these sponsors, events like this would not be possible. So we're really appreciate their investment in BIM Copenhagen. And I'd like to hand it over now to Riccardo. But before, I'd just like to make a few notes. As one is this event will be recorded. And we have Jakob Christensen as our moderator. And we'll be taking questions at the end of the presentation. So if you have questions, just write them in the chat. And Jakob will call on you at the end of the presentation to ask your question. And I think that we're all set to go. Riccardo, it's all yours.
Okay, perfect. Thanks a lot, David. Let me share my screen at first. Can you see it? Perfect. Yes, so thank you so much, David, and to the entire BIM Copenhagen group for this invitation. I'm really happy. I have been lucky enough to attend some other webinars in person as well, because I'm based here in Copenhagen. So thank you so much for the consideration. A few notes about myself. I'm Riccardo Piazzai. I'm an Italian architect living and working in Denmark since more or less 2017. And I'm the co-founder of NORDFY. I have been working in Italy, in Japan, and of course in Denmark, but always in the field of BIM and design. So my focus is in between the design technology and design, and how to combine this kind of creativity side of the profession with a more data-driven mindset. I think it's important for this webinar also to mention that I'm currently enrolled in a second-level master degree in digital twin and artificial intelligence for the built environment. So I'm going to touch base on this subject as well. I want to start very quickly presenting NORDFY. NORDFY is a process-driven creative agency specialized in AI, BIM, and design leadership. So we have this strong focus on disruptive technology, but also design leadership, design process, design optimization. And what we want to do, our vision is to prepare the AEC industry for the future. What does it mean? It means that we want to help professionals and organizations to be future ready, to be market competitive, and kind of to make the process in our industry more digitalized. To do this, we have been creating 3 business units for different needs. We have an academy, an advisory, and the creatives. The academy is both an online platform as well as an in-person training, where we teach topics in between disruptive technology and also design principle, design leadership principle. The advisory has a similar focus, but we are targeting organization. company. So it's staff training as well, delivering of services and solutions. And in the creatives, we are trying to put in practice those principles, but in our own developers. NORDFY is built on top of 3 pillars, which are human intuition, technology, and the creative process. And for us, it's very important this coexistence of soft skills and hard skills. So this continuous loop between digital technology and strategic thinking and creative development. Last but not least, we are looking for a new emergent design model where our ideal future for the AEC industry would be to conceptualize, visualize, validate, and optimize the building design entirely in a virtual environment. So let's get started with the topic of today, is this introduction of AI to the AEC industry. So this is the agenda of today. I want to be honest from the start and explain what to expect and what don't to expect from this presentation. It's not going to be something about tools specifically. We're going to see something, but that's not the focus. It's not a presentation about a specific use case of AI. It's a very broad topic. So what this presentation is about is giving a general introduction to AI with the aims of building the foundational knowledge, let's say, needed to master the technology, to understand the potential, to understand where we are and what we can do with it. And because it's not focusing on a specific use case, we will try to touch base on many different aspects of the AI, different level of complexity, starting from the beginning to where we are today. So maybe you can follow up if you are interested in specific niche of AI later on or in another session. So I want to start from this new wave of AI that kind of got us unprepared. Everyone is talking about AI on social media, is full of posts about AI. We are also here to talk about AI today. So the question is, why now and what changed compared to the past? Well, I would say that since ChatGPT and Midjourney came around, there was an acceleration of AI in many different industries. And probably the main difference with the past is that now generative AI is more accessible, is more democratized. And usually when a tool is easy to use, when a technology is easy to use, also the final goal that you want to perform with this technology becomes more accessible and more democratized. So if we understand this principle applied to our industry, well, we are having a democratization of design, which is a very important concept, I would say. But I want to start from the really basic, because I have been speaking in the last few months with different categories of people, some very experts of AI, but some in our really have some misconception about what is it. So what is AI? Well, first of all, it's not something physical. It's not a robot. There are some misconceptions probably coming from the popular culture, the cyber culture that was influenced by, I don't know, Hollywood, cinema, this kind of stuff, where AI was always presented as a threat for the humankind, or it was something to fear almost. Well, of course, this is not the case. We are going to arrive to a very detailed definition, a clear definition of what AI is. But I would like to start saying that AI operates through the implementation of algorithms. And algorithms is a rule that a computer follows to perform a task. So stating the word algorithm is really important, because that means that AI can manifest itself in different forms. For example, probably even before the advent of ChatGPT or Midjourney, you have been experiencing some sort of AI manifestation, probably in Google Maps or Waze, when it's trying to bring you to the final destination. Here we are talking about predicting the shorter routes, predicting traffic, place recommendation, or maybe something that it's more on our daily computer is Google Gmail, when it helps us to complete our sentences. This is also a manifestation of AI. And then we have, I don't know, smart devices and virtual assistants. And here we are talking about speech recognition, deep machine learning, and so on and so forth. And of course, maybe the most classic one is self-driving cars, where these cars are equipped with sensor, camera, and then we can use AI with computer vision to recognize objects and track movement and understand, let's say in general, the driving environment, right? So AI was already among us. And all of this just to arrive to what I consider probably the best AI definition I came across, which is AI seeks to make computers do the sort of things that minds can do. So there is this association of putting a machine, a computer on the same level of the human brain, the human power. Now, we will start diving in this AI world more and more. So let's introduce two more concepts, very important concepts for AI. The first one is human parity. I don't know if you have been exposed to this term related in relationship with AI. So human parity refers to the point in which a machine can perform, an AI system can perform the same or even better of what a human would do to accomplish a specific task. In human parity, it's a very important milestone in data science in general. There are specific tests that we have to run to understand where we are on time. But the fact is that in the last few years, we achieved human parity, or at least the benchmark of human parity, in almost every single use case of AI. So now that's why it's now, right? That's why it's happening right now. In the second term, that it's really, really important, that it's very close to the concept of AI, the main definition that we saw just a few seconds ago, it's reasoning. Reasoning, it's really, really important. So in here, we have this example that I was testing in one of these models. This is Google. So I feed the machine with an image, particularly it's an image where there are a bunch of balloons attached to cables in a street with some trees. And the first task that I'm asking for is object detection, right? So here, even if maybe it's already quite straightforward for everyone because you have been using probably ChatGPT, Midjourney, this kind of prompt to something models. But it's quite fascinating because you remember a machine, it's able to read numbers. A machine is able to read numbers. And in here we have a picture with pixels. Pixels are translated to numbers. So the machine is able to recognize relationship in this picture. There is all a process behind. I don't want to go to the technicality, but the fact is that the picture, the model is giving me back exactly balloons, street, sky, and trees. But the interesting part of reasoning is that the next point I'm asking, okay, what happens if I cut these strings to the balloons? And the machine is giving me back a very detailed answer, probably something even more detailed of what a human being would answer to this very basic question. But I find this very fascinating, especially if you translate this basic concept of reasoning to, I don't know, some challenge that you may have in your daily life or in our industry or in the BIM environment, right? So human parity and reasoning. Now, a step below, I think it's important to make a clarification about some of the definition. Artificial intelligence is a term that is often confused because we use machine learning, deep learning, almost with the same meaning. This is not the case. We already saw what artificial intelligence is trying to make machine do what human can do, while machine learning is a subset of AI where through the use of some algorithms is able to identify patterns on data to predict a final outcome. So here we have two new terms that are really important. One is data, which is going to be a recurrent term. And the other one is prediction. Prediction is also something very, very important. And then we have deep learning. Deep learning is a part of machine learning that use neural networks to analyze huge amount of data, right? Huge amount of data. But again, we have this word that come again is data, a data set. And last but not least, maybe the most interesting one is generative AI, because with generative AI, we are able to produce new content from existing data. So we are able to produce new data from data. And again, the importance of data. So if data is so important for AI, we need to understand what kind of data, where do we find this data? Do we have any data in our industry that we can use to feed this model? Or can you think about any data on the BIM environment where actually the information seems to be the most important thing? Well, that's clearly a provocation, but to understand what to do with data, how to approach with data, we need to understand how these models are developed. So the first important division is from the past, the traditional model development, with the foundational model that we have today. We're going to see them in a moment. But let's say the traditional model are trained on different data sets that are really homogeneous between them. Like a data set is composed by the same type of data, and then the model is trained, and then you have a specific task that you can accomplish with this operation. So you cannot train a model on a specific data set and then pretend another output for something that was not trained of. For instance, if we look at the first one, we have a bunch of different models here: classification model, detection model, tracking model, action model. If we take the first one, we have the training data. Well, in this case, because it's a classification model, the training data, I see that the task is going to be about car, is going to be probably a bunch of pictures with a labels that it say, okay, this is a car, label of car. This is another car, label of car. We train the model on this rule, and the output is going to be a label. So we're going to give to the machine a picture of car, and the answer would be, okay, this is a car, this is not a car. But we cannot use the same data set to maybe detect action. So in the action model, the training data are probably completely different. We are not able to perform the same task. Now, the revolution is that with foundational model, we are actually able to use a diverse type of data set to pre-train a model. And then in a second stage, we can adapt depending what task we want to accomplish. Now, even though the computational power to train one of these models, it's bigger than the traditional method, well, this is much more efficient, because once the model is pre-trained, then you can really go crazy in many different directions. While with the traditional model, first, it's very costly, and second, it's very limited, because everything is divided in silos. And this example of foundational model is, for instance, ChatGPT or the one of Google. Now, I don't want to go too deep in technicality of data science, but if we want to apply concretely this methodology in our AEC industry, we need to understand how to do with this data. How do we train this data? What type of data can be used for something or for something else? So we have to talk about training techniques. Now, there are many, so this is really a huge chapter. Here I'm just mentioning the supervised learning, unsupervised learning, just to start to understand the differences, but of course there is also reinforcement and many others. So supervised learning, we are talking about task-driven labeled data versus unsupervised learning, where we have a data-driven approach and unlabeled data. What does it mean? Unsupervised learning, you have, the input, and you know also the expected input is the label. So it's the example we saw before with the cars. We train a model with a car and a label to let the machine understand what I want as an output. In the unsupervised learning, the machine has to find a structure in the data itself. It's not task-driven, it's data-driven. Now, if we go a layer below, for instance, supervised learning can still be subdivided in classification and regression. Now, to make a concrete example about our industry, and if we think about, I don't know, temperature, classification has to belong to a class, right? So a specific range of temperature are going to be considered cold or hot. So it's a class. It's going to be cold or it's going to be hot. It's a totally different story if I want to predict the temperature of tomorrow in Copenhagen. That's a specific value, right? So that's regression. Another example, it could be a wall crack where, I don't know, it's dangerous or it's not dangerous. It's belonging to a class. There is risk or there is no risk. Something different is if I want to know and predict the point of in which a specific structure can collapse under specific weight. So that's regression. But in simple terms, supervised learning, I know the input and I also know the expected output. Unsupervised, the machine has to learn by itself, by analyzing this amount of data, by finding pattern and structure within the data. So we saw that AI is here. There is this trend. Everybody's talking about that. We start to analyze what is it, some definition, some new concept, human parity, reasoning, and then what is machine learning versus what is deep learning. And then we understood the importance of data and how to deal with this data in the operation of training a model. It's a foundational model, traditional method. Now let's step back and see what is the real impact of all of this that is happening around us. Well, the first point is from the organizational level. It's a fact that huge organization, huge advisory firms have made huge investments in deploying AI system and adopt AI solution, both internally in terms of business operation, but also as a provide services outside that are bringing huge amount of return on investment in terms of time, reducing business cost operation, but in general, the final outcome of this process is it's really efficient. So this is what is happening at the organizational level from the market standpoint, how these markets are disrupted by this new technology. And then from the professional standpoint, there is also huge consequences. Let's tackle one by one. The workforce shift. This is a study by IBM. So if we see what was actually relevant in terms of skills in the past few years, we see that in 2016, proficiency in STEM was probably the most in-demand skills required by employers and organizations, while nowadays, the most valuable skill is actually time management and the ability to prioritize. So how do I read this? I read this that today, soft skills are more valuable almost of hard skills because technology is so accessible as we were discussing before that can fill that specific gap. So for instance, ChatGPT is something that everybody can use, even though you don't have, I don't know, programming skills or other sort of skills, right? So there is this shift in the skills required, where an obvious consequence is that people need to learn, people need to transform, to adapt to this new change. And here I want to make a comparison with something that maybe all of you are familiar with, what happened with BIM back in the days. BIM is one of these technologies that for sure disrupted the market, that for sure disrupt the way we used to operate, we used to deliver building, we used to produce and document and manage and coordinate the building. So the difference here with AI is that AI is way faster. We adopted BIM and we are still in the process of implementing and getting better and better in the past, I don't know, 10 to 20 years. But AI is going much faster. So we really need to take this seriously and learn, transform, adapt, get new skills very quickly. And then in the long, short term, there are other kind of consequences. For instance, people that already have a specific knowledge in between, I don't know, tech skills and soft skills are already considered much more valuable by organizations and employers. Those are the first that are able to adapt to the change because they are already used to do that. And the second trend is that some professions and some tasks are going to be obsolete, are going to be cancelled. We will not have specific profession because AI algorithms, this data-driven approach is going to perform that in a much more fast, efficient, and cheap way for organizations. On the contrary, even though this category of people is a risk if not kind of adapting to the change and evolving and studying new things, new career paths and opportunities are coming with AI. For instance, we were discussing before, but we are going to see also after, the importance of communicating with a machine. So the rise of this new profession like prompt engineering, right? A machine understands numbers. So how do we communicate with a machine now that we are going to use words? This is a profession. In addition to the compenetration of discipline, because this data science is coming more and more within our industry. So let's summarize saying that there is a change, there is the need for the change, the way we think and work. This is happening in many different industries, not only our industry, but AI was present already in some of them until a certain extent. For instance, I can think about healthcare or aviation. Aviation is using AI to optimize flight routes and fuel consumption, taking into consideration many different variables like, I don't know, weather condition or air traffic. So AI is already implemented and used by many different industries, but it's also coming with this new wave, with this new power of technology that is going to disrupt. Imagine the video or image generation or gaming. Those are industries that are maybe the first one feeling the real impact of AI. And if it's valid for every industry, of course, it's valid also for our industry. Now, here there is just a list of what AI can, of course, do and not do. But the reality is that as far as I see today, construction and operation are the first two stages, or let's say, that are going to implement AI in a certain way compared to the design stage, for instance, where we are seeing something is moving, but it's a little bit behind. And why I'm saying that? Because in our industry, AI is already used for digital twins, and digital twins are mainly used in construction and operation for now. I'm talking about safety in construction site. I'm talking about predictive maintenance. Those kind of operations require machine learning to predict specific outcomes, and they're already in use. Design is a little bit behind. Now, we are looking at many different tools and developers that are coming out with many way of automate our process also in design. So I don't really think the challenge now is find the best tool, because you can find the best tool for your own needs. Here the problem is more a matter of implementation of a new process, how to change process in an industry that it's really resistant to the change and to digitalization. And then the second challenge that I see is the lack of skill, because to implement a new process, you need also a very hard set of skills. So working on the processes more than on tools. That's the need that I feel is the most important for now. And I'm talking often about this digital twin. And as I said, the reason is because digital twin is already using AI in some form, specifically machine learning, and specifically because it's adding to our industry another value, the value of prediction. This is something that for me is super important. As I said, is mainly for now in construction and operation, but my focus, my area of study is let's say, bringing this value of prediction into the design stages. And this is connected to one of the concepts of digital twin, which is called front-running simulation, where you are able to cover the entire life cycle of a building, of the delivery of a building in a digital environment, right? So to understand how AI is used so far in digital twins, I want to step back for a moment and understand what is a digital twin, because I speak with so many colleagues that have a little bit of confusion, saying it's a 3D model, it's a BIM model. Of course, it's not this the case. You should know we have 3 types of model, maybe more, but now let's focus on those. We have digital model, we have something called digital shadow, and we have something called digital twin. Now, the difference between a digital model and the other categories is the intelligence component. So in the first one, in the first example, in the digital model, you have a replica of the physical asset where you don't have any automatic exchange of data unless automatically manually driven. A digital twin, on the contrary, it's one-way automated flow where through the use of IoT or sensor, we can collect a bunch of data from the physical asset, inform the digital shadow, and take decision about the simulation, the analysis that we are going to do with machine learning, with AI on this, and then manually apply this decision making to the real world. Digital twin is the most interesting one, of course, because the data flow is automated in a bidirectional way. So what happened? IoT sensor are able to collect some data that feed into the twin. The digital twin are able to perform some prediction, and they are triggering a task in the physical space. Let's imagine that you have a meeting room that is not going to be booked for the rest of the week. We know this. This information is going to the twin, is going to make a prediction based on past data and stuff like that. And so in that meeting room, we can automatically turn down the heating system or the air conditioning. So we have energy savings, right? So this is a little bit the logic. Now, we need, again, data, and we need a platform where we can kind of collect this data and use AI and machine learning on top of it. So here, there is another aspect that is trying to combine the two worlds, what we already have, the BIM side, with this new data science discipline, which is the data curation. So far, we were producing a crazy amount of data with our BIM models in different formats, in different extensions, that at the moment of the delivery of the project, it's kind of lost. But now we have to go through this process of data curation coming from different sources. So we have also to be conscious that they have a different format and extension to then feed an AI model that can predict and accomplish specific tasks. Something that I'm focused on in the later stage is predictive maintenance and energy saving, which was kind of the simplified example of the meeting rooms, right? So what is the role of BIM in all of this? Well, BIM is crucial. BIM is crucial because it's where we generate and store many of those information that we are talking about. Of course, it's not all of them, especially because we are living in a physical world with other source of data. but this is a very important component. So how we can use BIM data to enhance AI? Well, first of all, I want to put BIM at the center of the digital revolution at all, not just thinking about AI now because it's the trend, but there are so many other disruptive technology that actually are having BIM as the core, because there where you actually store and generate information, you manage information. And then I want to see kind of a package of digital twin, BIM, and the common data environment, kind of the same thing. I want to see digital twin as the natural extension of the next level to be achieved in BIM, also in design. And here the important aspect is we understood that AI can work only if we have a pool of data to use and to make this prediction more and more and more accurate. And we know that BIM is producing a huge amount of information. So this new technology seems to be very complementary. They can really work together, right? It's not just about geometry of information, but it's looking at this new methodology as just one thing, let's say. Now, I think another important aspect to mention is implementing a new methodology from an organizational level, from an industry standpoint, because we saw back in the days with BIM that there was the trend, BIM was so urgent, we felt the urgency of adopting BIM, and people without knowing very well what was it about say, yeah, let's buy a couple of Revit license. So you are using Revit, you can sell yourself as a BIM company. Now we know that that's not the case. BIM must be implemented at different level, from the strategic level of leadership to the organizational level of a corporation to the project level. So there are different level of implementation, right? At the same time, there are different aspects that we have to consider: policy, people, training, technology, processes. So we don't have to do the mistake we have done before, that it took a while to actually implement BIM in a certain scale in an industry level, but actually approaching AI not as a tool, but as a methodology. How can we implement AI, integrate AI in something that already exists, which is BIM? How can we enhance BIM, and so on and so forth. So here I'm talking about strategy, right? Now this strategy has to start somewhere. So with this diagram, I want to explain what's the current state of how we produce information. And we produce information with something that we can define automated process. So BIM, Excel, CAD, those are automated processes. You need an input to produce an output. Now, this input and output is often stored and indexed and organized and trying to find a logic in something that we define the common data environment. So we have the automated process, and we have the common data environment that is trying to give an order and an index and find a structure to this data that are coming from different sources with different format, with different scope, if you like. Now we add an additional component, which is the AI component, right? So we have this third level, which is called autonomous process that don't need an input, but can by themselves perform and give an output. So I believe that the combination of the automated process that are still part of our industry, our working daily life, the common data environment, where we store, we organize, we index, we reference those information, and the autonomous process, this process that don't need any input, are going to disrupt the way we actually operate in our AEC industry. Now, from where to start from the operating level, right? Okay, you have to start tomorrow. What we are testing is find new tools, maybe coming from different disciplines like data science, integrating much more data science and integrating much more business intelligence into the way we work with information within the BIM discipline. So we have our Revit file, we have our BIM 360, we have our common data environment, but we want also to combine with something else. So I don't know how many of you are familiar with NIME. NIME is a data science platform that it works a little bit like Grasshopper for Rhino or Dynamo for Revit. So it's a visual scripting that has some components of AI, machine learning. So you can train a model, you can predict, you can make assumptions. And then something that I think should be mandatory in our industry is BI, business intelligence. If information are so important, I think we really need to be able to read this information, but read this information at the same way we are able to read a detail of a curtain wall or something like that. We need a plan. We need to be able to read business intelligence. And then we are testing also this card. I know many firms actually develop some kind of tool in-house. We are testing VCAD. VCAD is this platform that allows to combine the common data environment, 360 Revit with BI. So you have the model and you can display information in a more efficient way. So again, the connection with the theoretical aspect we saw before, common data environment, the AI component, and the business intelligence, which is also very, very important to me. Just a very quick look about how NIME works. NIME is exactly as Dynamo, is this visual scripting. So here is a very simplistic exercise. So the orange component, the first one, is the data set. I just load an Excel file, a CVS file, whatever. And then the second step, the yellow one, is partitioning the data. So I split the data, 70% to train the model, 30% to test the model. And then at the end of the process, you have a score that it gives you feedback and statistic of the accuracy of that prediction. How many times the model, based on that rule, gets it right or wrong. And then you can adjust the rule within the component. So this is really something I invite you to take a look and to embrace in your workflow, because you don't really need a huge knowledge about programming or artificial intelligence. You can get there very easily. Then a more complex approach is, of course, with programming. I'm really new to this world. I'm using Colab to train. Like this is an exercise. It's not even based on our industry. It's more based on a random exercise. Here, the data set is handwritten numbers with a label. So it's supervised classification, right? We saw it before. And I'm trying to train the model to predict which number is what. But the components there are pre-made, so you can actually change them. And then you have a bunch of tools that this is not a complete list. Of course, there are so many others. I think Stefan, if you know Stefan from Big, he made a huge list of available tools. Check it out. Here, just to stress out how every single stage of the project is affected by AI, and how these tools are trying to automatize and solve problems in every single stage. It's really important to talk also about the art of prompting. This is fundamental because we saw a machine reads number, right? But we are feeding a machine with text. We are talking about this generative AI, which is prompt to something, text to image, sketch to image, prompt to 3D, and so on and so forth. So we really need to understand how to communicate with the machine. So far, we were using a mouse as an extension of our arms, conceptualizing our operation as we would do in the physical world. But now we have to communicate with a machine with a different language. So this is going to be very important. And here it's something that after, I mean, I have been attending the BIM Coordinator Summit in Dublin. there were so many speech about AI, and so we are trying to see how to reinvent also the design process in the early stage, where you have a current state with sketching, and maybe you find some references, you use Pinterest, you use Google Image, and then you have also numbers, right? You have area, you have a program to fit, and then you start 3D modeling. So we are start to see how we can implement these tools already able and test them out, like what the process could change to be more efficient. And if you see, there is always a human component, and then there is a human machine co-working together, and then there is only a machine. Now let's focus only on the first process reinvention. So here, what we are trying to do, we have a sketch, we have an idea. It's in combination with what we generate at the beginning. It's in combination with what you can generate with AI. So it's not more looking at reference from other, it's more producing together with the machine, which brings to the design process something that I really like, which is the surprise effect, because you don't have something prefixed in your mind, but you always get surprised from the result of AI. And then there are other AI-driven tools that are not only using AI, for instance, IPA. We are going to see a demo of it where you can do test fit. So from this test fit, you have a 3D model, and then you can refine your design. Now, I want to stress out that it's fundamental to work together with, of course, the design intent, the narrative, the storytelling, but always with this continuous stream of data management and computational analysis, because we don't want to base our design only on numbers and images of aesthetic. We want a sustainable building. We want a performative building. So the design process must always be together with these other aspects that maybe were not clearly described here. Where these new processes, these new reinventions of the design process would lead? Well, if you look at the current design process, we start with a brief and then different design options. And then you take some design decision, you remove some design option, you bring the level of detail of this design option because you have client meeting, because you have milestone, because you have deliverables to the next level, and you discard some of these design options until you arrive at the end with only one possible buildable solution is your final design. With the new mindset, what is going to happen is that you feed the machine with some parameters that are fixed, that we know we have to respect. And those parameters can be any kind of parameters, program, raw, regulation, any kind. And then there is a first filter, which is AI assisted. So this human working together with the machine, and you have a bunch of design options that, pay attention, they are all of them are equally good, maybe different, but in terms of performance, they are equally good because are parametric driven, are data driven. So you can actually bring to the next stage of the design multiple design options, choosing one, of course, but multiple design options with the same level of complexity. And then you remove a lot of these design options by going through a design decision. So the first step is performance decision making. The second step is design decision making. Of course, there is also the human final decision that is curating the design. Say, no, in this context, in Iran, we need this project because we have a different cultural understanding, we have a different background, a different heritage, compared the same building, I don't know, in Abu Dhabi or in Copenhagen. So, of course, there is a human component that it's probably must be there for the design curation. So to conclude, I want just to quickly showcase a few tools. One is IPA. IPA is really, really powerful. Check it out if you don't know it, because you don't start the project from a blank sheet. It's not starting from scratch. First operation, text to BIM. So you describe the massing, you describe the architectural component. You can say, I want this structural grids with this dimensioning. I want a podium plus tower. I want to move the tower. I want to reshape the car. I want to move the car, and so on and so forth. So it's all text driven. When you have something that's more or less what you want, so you are not really starting from scratch, you can perform in the same environment your test fit. So you can going a little bit deeper with detail and understand, yeah, I can fit this program with this layout, or I need to make this modification from what was originally generated from the machine. And you start to curate the design, but with information, right? And after all these processes is over, you can import this data in your authoring tools, this case of Revit, and you have your Revit family, and you go not from scratch, but you have already your drawing set, we can say. Another one, just to tackle another problem, is Blueprints AI. In this case, is something that you have kind of a chatbot to generate your drawing set and your BIM model, and you can modify the design and the drawing based on text. This is really powerful. For instance, here I can say, yeah, but I don't want this garage, or I want to add an extra storage, or I want an L-shaped living room, open space with the kitchen, and so on and so forth. When I'm really happy with my design, I can make the software to generate a more complete BIM object and produce all the documentation. So really an entire drawing set based on the stage of the project, right? If it's schematic design or development design or whatever it is. So if the direction is this one, this is really scary as well, I would say. And then we have, of course, some form of Lunchbox ML. Here, for instance, is a more integrated version with Revit, where changing the geometrical relationship of the boundary, the machine learning can predict what room that is going to be. If it's very narrow, it's going to be a corridor. If it's a specific square meters with some dimension on a side, it's going to be another kind of rule, and so on and so forth. So the prediction apply to a Revit use cases. And then there was this one that I'm sorry because the graphic is not the best, but it's a very simple starting point that I saw from this person, from Gokar Malik at the BIM Coordinator Summit, that I really want to show you because it was really nice to me. So what he did was importing geometry. This is just math, where in his mind, in a human mind, because a column, a slab, a wall has specific geometrical characteristic or has specific predominance or specific dimension versus the others. For instance, a slab is really wide, really depth, but it's thin in proportionally speaking. He wants to predict what kind of element would be assigned to a 3D object in the space. So he wrote a few lines of code, and then he mapped the situation that, for instance, if a column is in his normal position, so in a vertical position, it's considered a column. But if you rotate the column horizontally, well, that could be read as a beam if you don't have any other information, right? Just geometrically speaking. So he wants to train this model where the output 0, 1, 2, and 3 means 0 is a wall, 1 is a floor, 2 is a column, and so on and so forth. This is kind of the pipeline, so TensorFlow, Onyx, then some scripting. And here's the final result. So now it's a little bit hard to read, but when you select one of these elements and you run the plugin, the tools predict what that should be. So the first was a wall, the second was a beam, this is going to be a wall. And of course, when he would manually update the geometric relationship in the dimension of one of these elements, the model is going to predict a different output. So for instance, now this wall has the change with different geometrical proportion. The model predicts that this must be a beam. If now we extend this surface to be more horizontally spread, okay, this is going to be a floor. Now, the interesting part is that when the geometry, in this case, for instance, is so different compare all the numbers he used to train the model, he's still able to understand the relationship. So this is a column, even if it's really exaggerated, because the geometrical relationship are those. Now, imagine if we start to have this kind of a control in Revit, where everything is a label, everything is a parameter, everything is a text parameter. I mean, if the model can predict also the parameters to fill in, it's really powerful to me. So I want to conclude this presentation with this sentence: creativity can be defined as the production of new knowledge from already existing knowledge accomplished by the problem solving. And that's because I think BIM, AI, human-machine relationship are really going in this direction, where it's data-driven, it's process-driven, and the value of prediction coming from existing knowledge that can generate new knowledge is going to be the future. So yes, that was it from my side. I don't even know if I was on time. Maybe it was a little bit long. I'm sorry for that.
Thank you very much, Riccardo. I've just have a little brief look at the questions from the chat box, and maybe we can have just a few. I don't know, David, if you want to make a roundup before we take the panel discussion. David, so maybe we just say the formal stuff, and then we go on to the questions afterwards. Is that okay?
Sure, that's fine. I'll just round off. Thanks, Riccardo. That was a super presentation. You hit the spot perfectly. So I'd just like to take one more chance to thank our sponsors for BIM Copenhagen. And if you like what you've seen today, just follow us on our LinkedIn channel. We have a website that is not quite active right now, but go in for LinkedIn and follow our BIM Copenhagen page, and you'll see more events like this in the future. And just like to say thanks for everybody who attended. I think this was a huge success, and I think I'll turn over to Riccardo and Jakob for questions. Jakob will be the moderator.
So I think the sound on now. Thank you very much, David, and thank you to you, Riccardo. I just invite Dimitros Theodore had a question around halfway in. Do you want to speak, Dimitros? Maybe. Then I can have another question if in between there's somebody who wants me to ask. He's first of all, thank you for your presentation. It was very good, and he's asking something about if you put you're learning your computer by data. How important is the data quality for the learning mechanism?
No, of course, this is fundamental, it's crucial, because I mean, then we go in a different field. No, it's the same field of data science, which is data curation, clean data, not clean data, how to clean this data. But I think here the crucial part is that most of the data coming from BIM are actually already clean, if you like, are diverse, maybe different format, different extent, but they are homogeneous in my mind when you want to apply the AI methodology. So of course, the importance of data is fundamental. Without data, we don't have any prediction, any AI. We need to train a model on data. But we have a very good starting point, I would say. We have been collecting data with our models for quite a while now. So that's where to start.
Thank you. Then people might ask again if it's not clear enough. So thank you for your answer. I have another one. Vits, I just try to invite you in. What about now? Could you make your?
Yeah, sure. Can you hear me?
Yes, perfect.
Yes.
Fantastic. Yeah, first of all, thank you very much for such a enlightening presentation. Just a quick one regarding the IFC, because Riccardo mentioned about Power BI, so plus some intermediate software to parse the data from the BIM models. So Riccardo, what are your thoughts or perception regarding the IFC future concerning topic of AI usage? Because basically IFC allows data manipulation, in my opinion, in much more flexible way rather than Power BI.
Yeah, no, I mean, probably you're right. The fact here, I think, is not focusing too much on a specific platform or a specific tool, but is more designing the process now, how to create that connection. And the same could be achieved with different platform or data source. For instance, that connection that for me with BI, I was also talking about 9, but this is not a recipe, you know, this is not the only way. I just would say that it's increasingly important to fill that gap, because yeah, I think BI, as I was saying before, BI, business intelligence, should be part of our toolkit as designer in our daily life. And so that connection could actually happen in many different forms. I agree with you. It's
all right. Thank you very much. Thanks.
Cool. I think I have that's almost all of the questions. There's one asking about civil engineers. How do they start a career in BIM and AI? Do you have some talks about that?
I mean, that's not really my background, but I mean, I think AI it's going to help every single profession within our industry, right? So it's not if you are a designer. Today was more designer oriented because this is my background, but we saw it's going to help at different stages of the project, but it's also going to help different stakeholders involved to design process. I saw it was not written in the presentation among the possible tools already available, but there is Consigli that, for instance, it's already tackling with strong solution the AI world for engineering and this other side. So I think that's going to happen to every single profession. It's not just a matter of design. Now, specifically what's the path in that specific field, I'm not confident enough to say it, because I mean, I'm not a civil engineer and I don't know every single step there.
Thank you. And then I have a last one. I think I'll try to get Dimitris once more. Oh, Dimitris, here you are. Try another time. Then maybe the sound.
Hi. Can you hear me? Great. Great. Riccardo, first of all, thank you for your presentation. Really insightful. My question goes basically to the data sets that you were discussing previously, and the fact that in the ICOM industry, we're definitely talking about data siloing. In the terms that nothing is publicly presented, and you need to generate your own data effectively in order for you to train your own models in the progress. So I would like your point of view with respect to that. I mean, how do you go about and overcoming that issue with the data siloing? Since we don't even have, let's say, a data lake or a data warehouse at the moment.
Yeah, no, I mean, this is a good point, and I think it's probably the hugest challenge right now. It's not really AI deployment, but it's how to curate this data in a certain way and how to have consistent amount of data that we can use. Now, even though we can have this data coming from BIM in different source or from the build environment, because I mean, it's not a BIM models or the management documentation that we collect over the delivery of a project is the only source. We have also our built environment where we can like extrapolate existing information from the built environment. That could be, for instance, another approach. Monitoring what we already built, how it was built, regulation. It is also different case by case, right? In China, they used to operate in a different form than how we do things in Europe versus maybe in New York. So yeah,
exactly.
I see for sure the challenge there, but I think we should start from, I mean, our local situation. Maybe we perform in a specific market. Maybe we focus on hospitals only. You know, there are initial steps that we have to accomplish anyhow. Of course, we will not solve this problem all at once at the beginning in the next year, but I don't know, a company that is the specific niche is hospitals or hotels, where there are specific layouts that are maybe repeating, or maybe the regulation where they are operating is very similar. Maybe the fire escape route is very consistent across the region. So you have a bunch of information that are actually rules that you can use to train your little data set for now. But I see the challenge. That's what we have to probably solve, to implement in a larger scale, in a global scale, because yeah, what happened in China is different from what happened in New York.
Thank you for your answer. If I may add another question, coming from a construction firm, I see a really, or needed actually is generating, let's say, procurement and tender offers for the various clients, but at the same time, that also extends to sustainability, meaning using in our offers, let's say, the various materials and products that are sustainable and more appropriate, let's say, for green building construction. With that, again, in respect, it's what you have described previously, but at the same time, it's a more localized, because it's a different issue. How do I construct something here, whether rather than, let's say, a town that is 50 kilometers from near to me? So yes, I understand it's something that has to be treated, but I think that the treatment has to be at the very localized version. Speaking from my perspective as part of the construction industry.
Yeah, I understand. But okay, let's try to tackle the problem in this way. Now we saw, for instance, this pre-trained large language model that we are trying to build on top of it. But the real competitive business advantage would be when company would be able to work with their own data, with their way of operating, with the way they construct. So you would not be limited to a specific workflow that is given to a more open way of, I don't know, doing detailing. You were doing this example, but it's really custom tailored for the needs of your company, for the way of your region it used to build, or the regulation that you have to face when you deliver the project within your geographical area. So I think there maybe it's where we have to do something. So if NORDFY, Riccardo Piazzai is working with specific clients in a specific niche with specific market, I will train my own data custom tailored for what my need is. That is probably different from what a different person in a different side of the world accomplish the same task with the same kind of regulation has to produce a different output. So the model is custom trained in that sense.
Great, thank you. I will keep in touch, definitely. Thank you very much.
You're welcome.
Thank you for your question. And I think that was the last one. So once again, thank you very much, Riccardo. I think it was a very interesting and informative talk you had. So
thank you so much for inviting me.
No problem. Be another time, I think. David, do you have a last word?
No, I think that was a great presentation. I think it was really appreciated, and I'm really happy that so many people came to hear you. I think this was a really good insight into AI and the AEC industry.
Thank you, David. Thank you. I appreciate it.